Okay. Yeah, so I'm back. Okay, so let me continue from there. So like I was saying, here it's either we are considering one to be positive or negative if we are going to consider the direction. Okay. Now, if you factor in the direction, which means that you've already factored the direction. So whatever answer you gave, you take into consideration the direction you employed. Okay. But once we did not factor the direction, then the final answer you are going to get will tell you where the object is moving to with regards to the other object. Yeah, so now let me take the hands, Richard.
Sir, please, can you go over it again?
Okay. Everything.
Suggest the from 0 is equal to MV plus big MV. Just that one, the second
Okay.
step.
Okay, this step is just a change of subjects. Okay. So let's take these ones away first. Those ones are further explanation. Okay. So what I'm saying here is by change of subject, if this goes there, okay, it's going to be negative. Okay. So that is, and then we divide through by m. So that will be minus mv is equals to what? Is equals to mv. Okay. Then we divide through by capital M. We divide here by capital M. Okay. So which means that v is equals to negative m v over what? Over, sorry. So negative mv over what? Capital what? Capital M, like we saw here. Okay, good. And then once you fix in the value, small m is 0. That the velocity of the bullet, which is small m, is 80 meters per second, and then your capital M is 100 kg. Okay, so you get negative 0. What? Negative 0.016 meters per second. Meters per second. Okay. Now I was explaining something after that. I said at this point, before you get here, okay, before you make the subjects, if we were going to consider the direction, and then you decided to keep this as positive, meaning this is going to the right, let me construct a gun like that. Okay, so if you are considering the bullet to be moving in the positive direction, okay, with a positive velocity, then the recoil speed will go backward. Okay. So here I'm saying that if you factored that into this equation here and made this plus and made this negative, okay, then at the end of the day, because you've already decided that the direction of the gun will go to the left, okay, when you make, let's assume this is negative here, then it means that when this crosses over, you're going to get negative mv, okay, over minus what? Minus m, which is equals to v. So which means that your velocity will now end up as what? Positive what? 0.016 meters per second. Okay. But here, because you factored the directions of the motion, okay, then this value you are getting here is the velocity, but the direction, the speed, but the direction has already been indicated up here to the left hand. Okay. But in the first calculation, we didn't factor the direction in. So at the end of the day, we got a negative. The negative tells us, okay, that the direction of the gun is opposite to what? The initial or the direction of the bullet. That is what I was explaining. Okay, so let me clear the screen and then we'll move on to the next. So it says that the negative sign indicates that the gun moves backward, okay, whilst the bullet moves forward. Okay, then we have case 3, where we have two bodies coming together before and then they are going apart after. Okay, so in this scenario is the same. Okay, the same law you're going to apply, which is momentum before. Okay, momentum initial, or let me put it that way, is equals to what? Momentum final. Okay, good. And then because both bodies have mass and velocity, this velocity here will be negative per our convention. Okay, this will be positive, this will be negative here. Okay, this will be what? Positive. Okay, so like I said earlier, once you incorporate the direction before you solve, okay, then your final answer you have to interpret with regards to what the initial directions that you have already assigned. Okay, so if you write this equations, it's going to be what? M1 V1 plus M2 V2 initial is equals to what? M1 V1 final plus M2 V2 final. Okay, but you have to take into consideration the direction, okay, of each of the masses. So for M1 here, the velocity is plus, but the velocity here will be negative. Whereas when we come here, the velocity here will be negative, whereas this is going to be what? Positive. So you take note of that. Yeah. Yeah, so we have an example here. Please try and raise your hand before you talk.
Yeah.
Try to raise hand before you come in.
Okay.
Okay. Set.
Yes, sir.
Yes.
Sir, please let me greet you before. Sir, good afternoon.
Afternoon.
Yes, sir. Please, my question is the direction. Are
Yes.
they going to indicate the direction for us, or always we the student we should bear in mind that what I'm trying to say is that the direction, are they going to indicate it for us, or we the student we're supposed to know?
You are supposed to graph it. Okay, so you are supposed to graph, because the direction I want to use will be different from the direction you want to use. Do you understand? So like the full back and the line backer, okay? You may want one object to be on the left, this one will be on the right. But in the scenario where I have indicated the masses as a diagram for you, then you will have to indicate the direction of the object. Yes. But if it is not given, you will have
Okay.
So there is a demonstration here.
Okay.
There is a demonstration here. It says the body A of mass 10 kg with a velocity of 3 meters per second makes what? Okay, so makes a head-on collision with a body B of mass 5 kg with a velocity of 2 meters. So what you first have to do is you have to indicate, okay? Now we are saying that a body of mass 10 kg. Okay, so we have a 10 kg object here, moving with a velocity of 3 meters. So you see, I have indicated 10 kg on the left. You would have indicated it on the right. Okay, but then the interpretation will still be the same as long as you incorporate the directions correctly. Okay, so 10 kg moving with 3 meters per second makes a head-on collision with. So head-on collision means case 1. Okay. Yeah, so head-on collision with another body 5 kg and moving with a velocity of what? 2 meters per second. Then let's see, it says if the velocity of the body B after collision is 3 meters per second, find the velocity of the body A. So that's case 3. Okay, so here, once they collide, they will begin to move in the opposite what? In the opposite direction. So this is a case 3 scenario. Okay, good. So we have 10 and then we have 5 here. Moving in the, so we don't know the velocities yet, but we are told that the velocity of B, which is the 5 5 kg, is moving what? After collision is moving 3 meters. Find the velocity of the object A. So this is how we go about it. So it's still conservation of linear momentum. Let's split the screen into 2 halves. So in the first case, it's going to be what? 10, or let's go straight forward. Okay, so we have 10, okay, times what? Just a moment. Let's rather start with the equation. So we have what? M1, which is for mass 1, okay, times what? The velocity of 1 initial, okay, so that's for I, plus we have M2, okay, V2 initial, okay, is equals to what? Is equals to M1 V final, V1 final, and then plus what? M2 V2 what? V2 final. Let's clear this side. So this V2 final. Okay. So like we said, because we have illustrated this to go to the right, which is positive, by conversion, this will also be negative, and then this will be negative, and this will be what? Positive. Okay. So it is this velocity we are asked to look for. Okay, that is what we are looking for. That would be V1F. Okay, V1F. Right. So we can, let's rewrite the equation in this form. Then we set the the directions. Okay, so that is going to be M1. So this implies we have M1 V1, okay, initial, plus what? M2 V2 initial over, okay, where are we? We are looking for this. So minus, this has to go, okay? So minus what? Minus M2 V2 V2 final. So V2 final, okay, over what? Over M1. Okay, so that is the formula we are going to make use of. M1, okay, good. Now let's clean this side and let's write it down here. So now let's examine the direction. We know V1 here is positive. V2 initial is negative. We know, how do we call it? M2 or V, where is it? V2 is what? V2 is positive. Okay. So we are going to include it in our formulas here. So let's rewrite this. This is going to give us, we have M1, which is 10, V1, which is what? 3. Then we have plus M2, which is what? 3. And then V2, which is what? Negative 2. This is minus 2. Then we have minus what? M2, which is what? Which is 3. And we have V2, which is also what? Which is, no, I think M2 is 5. I'm not capturing it well. So M2 is 5, not 3. So we have, so we got 5 here. We got 5 here. And then we have 5 here as well. And the velocity 3, yeah, that is it. Okay. So then all over what? M1, which is M1 is what? Is 10. Okay. So do the calculation from your end. Let me have it. So here we've incorporated the direction. Okay. So whatever value you get, because you've already incorporated the direction, you know where it is going to. So this will give us, when you do this calculation, this will be 30.
1/2, sir.
30 minus what? 10 minus 15 over what? Over 10, which will be what? 5. This 30 minus 25 is what? 5. Over 10 will be 0. What? 0.2. Okay, so V2 final. Yeah, I'm seeing a hand up consistently. Yeah, 1/2. Okay. 1/2. Okay, good. Yeah, so this V2 final is 0.5 meters per second. Okay, and like I said, okay, because we've incorporated the direction and we know that V2 from our diagram here, V2 is moving to the left. Okay, the velocity we've estimated simply tells us that we are going where? On the left side. Okay, so you interpret your results in light of your diagram. You understand? So if you don't present diagram for such a question and you present your results, I wouldn't understand where your direction is. You have to present the diagram for me to know where you are headed. Okay, so take note of this computation. Yeah, any question?
Hello, sir.
Okay, so try the second question for me.
Hello, sir.
Yeah.
Hello, sir.
Yes, I'm listening. Try and read
With the screen.
with
Yeah,
the,
my hand is up.
yeah, go ahead.
With the calculation.
Yes.
Yeah, right now. If you should divide it by the V1, which is the 5. Is it the V2? The V2 rather is the 5. If you divide it by the 5.
Why?
Does it mean that you change the direction? Let's assume, and you divide it by the 5. What will be the outcome?
By 5. Why do you want to divide by 5? Eric,
Yes, sir.
the person asking the question, Evans rather. Evans, why do you want to divide by 5? Can you type? I'm not hearing you. Can you type Evans so that we know why you're asking your question? Whilst we take Amuzu's hand is up. Amuzu, you can speak.
Sir, please.
Yes.
Sir, please, the answer for V2, we had 0.5 meters per second.
Yes.
But the direction is negative, but it's not like the Evans, I don't know.
Yes.
So should we add the negative?
No, Amuzu, try and understand this. You have already indicated the directions in your diagram here. Okay, so you have made
Yes, sir.
use of the direction on your diagram in your computation. Okay.
So there's no need to add it to the answer.
No, not at all. So when you are interpreting,
Okay.
like I was saying, you interpret with regard to this question without a diagram for me. I will not know if you say it's negative 0.5. Negative 0.5. It was your 10 on the left or right initially. You get it? So you need to give me the diagram. Then your diagram will tell me what your positive, what the positive word means, or whether you had negative, what the negative word means. Okay, I'm here to hear from the first guy, Evans. Evans, could you just type your question so that we address it for you? Okay, I've seen another hand up. So 06Y, come in.
Hello, sir.
Yeah, let me take your question.
Hello, sir.
Yes.
Good evening. Good afternoon, sir. Please, sir. With the second question.
Yeah.
When the two bodies together, would their common velocity be positive?
That's case 1. So that's case.
I wasn't there before. Sir. Sorry.
Okay. Okay, Eric says, will it mean the body will go to right? No, it won't go to right. It's the same question as Amuzu is asking. Okay, you see the analysis we've done, this analysis we did, making this positive, making this negative, making this positive, was based on the direction we've indicated here. We said that this V final should be negative. This should be positive. This initial should be positive. This should be negative. That is why when you get an answer of positive, you interpret the positive in light of the diagram you have here. Okay, this value you have here is what? 0.5. But on your diagram, you have already indicated that the direction is where? To the left. Okay. I think we saw a similar scenario on the case 2. Okay, where I indicated to you that without the direction, the answer will be different from with the direction. Okay, and both of them are interpreted in this, you get the same interpretation. But once you have incorporated the direction, when you get a positive, interpret it with regards to the direction you have indicated. Now let me take another a negative case scenario so that you understand better what I'm saying. Somebody else could have made this 3 rather come to the left hand and this come to the right hand. Okay. So it means that we have this direction here and that direction here. Okay, so if we are including, then it means that the velocity of this first body here will be negative. This will be positive. Okay, and then when it comes to everything will change, which means that your final answer will still be what? Will still be what? That you have to calculate and find. Okay, but the interpretation of it will still give us the same results. It will move in the opposite direction. Ivan says, I was asking if you should divide by M1 V1, which, if I'm correct, is 5. What will be the outcome? We are not dividing by M1. Okay, the velocity, what you are looking for, what you are looking for is V2 final, V2 final. Okay, so which means that we're going to have, sorry, we are rather looking for, this is M1 also. This is M1, this is M2, this is M1, this is M2. So we are looking for the velocity of M1 here, okay? We are looking for the velocity of the bigger body, which is M1, right? So which means when we are doing the change of subjects, M2 will have to cross the equal to sign. Then you divide through by M1, okay? And the M1 is the bigger object, which is 10, not 5. Okay, so take note of that, Evans. Okay, I think we've dealt much here, and I don't see any hands up, so we can move on. Yeah, I was asking you to solve the second question for me. So everybody try it for me, and then okay, somebody already has the answer. Yeah, another confirmed answer from Joshua.
Hello, sir.
Please, have you raised
Hello,
your
sir.
hand? When you raise your hand, let me walk you in. Yes, Richard.
Sir, the second question, I had negative 1.3 meter per second.
So somebody also had positive 1.3 meter per second. And your interpretation will be done in relation to the way you constructed the objects. You see, so if you tell me negative, how will I know where your objects are going? Whether you placed A on the left or on the right, I can't tell. You have to show me the diagram before I'll know the meaning of your negative. I hope you now understand.
Yes, sir.
So you have to show me your diagram before I can interpret it.
Per my diagram,
yes,
the 10 kg mass of body is going to the right direction.
Okay.
And the 5 kg body is going to the left direction.
Okay. So when you were solving, did you incorporate the direction into the calculation?
Yes, sir.
And then you had what?
So, and I have negative 1.3 meter per second.
Very good. So for the, where did you consider to be? Just a minute, let me take your diagrams first. So for your diagram, you said you had.
Sir, yes, sir. For my diagram, the body A, which is 10 kilogram,
yes,
is moving to the direction, towards the right direction.
To right. Okay.
Yes, sir.
Okay. So.
And then the body B of 5 kg is moving towards the left.
To the left. Okay.
Yes, sir.
So 5 kg with velocity of what?
2 meter per second.
2 meters.
Yes, sir. And the 10 kg is 3 meter per second.
So at the end of the day, if the two bodies stick together after impact, yes, so the two bodies will come together. We don't know what direction they are going. You understand?
Yeah,
So
yes,
final
sir.
direction
Yes,
is
sir.
unknown. Okay, so that is case one scenario. So you go by the same formula, which will be M1 V1 initial plus M2 V2, okay, plus what? Hey, sorry, is equals to what?
It's equal to
M
MVF.
yes, MVF. Okay, so that's case one scenario. Okay,
Yes, sir.
so if we want
Yes, sir.
VF, okay, we have M1 V1
Yes, sir.
plus M2
Plus M2 V2
V2 over
over
M.
M.
Okay, so now then we add the directions to it. So per
Yes,
what
sir.
we said, this is positive, this is negative. Okay, so let's go and incorporate. M1 is 10, V1 is what? 3, M2 is what? Is or let me put it this way, M2 is what? 5, V2 is what? Is 2 negative. Okay,
Yes, sir.
yeah, all over the total mass will be 10 plus 5, which is what?
10 plus 5.
15. Okay, so when we calculate here, this is a 10, this 30 minus 10, which will
Yes,
be 15.
Yes, sir.
15 over,
No, sir. It's 30 minus 10, which is 20.
20 over 15.
Yes, sir.
So we get 20 over what? 15, which will give us 1 point what? 333.
1.3 meter per second. Yes, sir.
Okay, so 1.333. So now the question here is, we do not have an idea of where this object is what going to, whether it's going to the right or to the left. Do you understand? So the
Yes, sir.
final direction here, the answer you get here will tell you where the object will move. So in this case, you are getting a positive, right? Positive 1.3. So positive 1.3 per your diagram here. You said positive is to the right, which means that these
Yes, sir.
two objects will end up moving to the right.
To the right.
Yes. So for those who reversed it, you get a negative. Okay. So if you reverse it, you will
Yes,
get
sir.
negative. And the same interpretation is what you're going to get.
Yes, sir.
Okay. Yeah, I've seen charts. I used A from. It's the same thing, Joshua. It's the same thing we are saying. So those who use A from the left all had positive, and those who use A from the right will get negative. Then I've seen a hand up. So that is 06Y. 06.
Yes. Hello, sir.
Yeah, come in.
Please, sir. I don't know whether I'm getting it from the right side. Is it that because the M1 is bigger than the M2, that's why the body is moving to the right side, or I don't know? Because
I don't get your question clear. Where did you put body A?
I mean the mass. I'm talking about the mass.
Yes.
The mass, the M1, which is for the body A.
Yes. Okay. So your question has to do with, in practical terms, why is it moving to the right? Is that not so?
Yes. Sir.
So once again, the same question somebody asked earlier. We are talking about momentum, ability to move. Now look at the ability of motion for the first object. 10 times 10 times 3. That is 30. Whilst this one is 5 times 2, which is 10. So who has more ability to influence that?
Yes.
Okay, set.
I think it's the A. It's the A.
Yes. Set. Your question. Set, come in. Seth, unmute yourself and speak.
Hello, sir.
Yes.
Sir.
Yes, I'm listening.
Sir, please. So when it happens like, sir, please. So when it happens like that, those who get the negative, are they correct or wrong?
You're correct. But the interpretation
okay.
will be done based on your diagram.
Okay.
So you are both correct. Okay. Good.
Okay, sir.
Okay. Any other question? Yeah. If not, let's move on. Okay. So the next thing we want to look at is work, energy, and power. This we have an idea of. Our second session is almost expired. I have like 3 minutes, but let's see what we can work out. So it says work is done when on an object when an applied force move the object through what? A distance. Okay, this we all know. And we know that force is basically equals to what? Force times work is equals to force times distance. Then the next point here is, it says energy is defined as the ability to do work. So mathematically, we all know that force is work is equals to force times what? Distance. Okay, that we are all aware of. Now, before we come to work down by varying forces, I want you to use your knowledge from previous class to find the work done, okay, on the system, okay, in the x direction for me. So I have force of 200 Newton. Okay, then the direction here to the horizontal is, let me say, 30 degrees. Okay, I give you the mass of the object as let's say 50 or 60 kg. Please write the question down. 50 kg. Then we have, so this body is going to move. We are moving from this point, okay, to a final distance here, which will be, let's take it, let's take 3 meters, okay? And I want you to find the work done, okay? Find work done in the x direction for me. So find work done in the x direction, the horizontal direction for me. And let's assume there is no friction on the surface.